have a discussion on this real number. In our previous class, we already studied Euclid's division lemma. Okay, the very first topic in this particular chapter. So, Euclid's division lemma. Sometimes it is also called as Euclid's division algorithm. Euclid's division algorithm. Okay. Now, what actually this Euclid's division lemma is? So, Euclid's division lemma says that any integer a, positive integer, any integer which is positive a, if it is divided by another positive integer b, then this particular positive integer a, which is greater than b, can be expressed as bq plus r. A is equal to bq plus r, where q will be, so it is called quotient, because when we are dividing something, okay, any number with b will be getting quotient, will be getting remainder. Okay, similarly r will be the remainder. All r and q are positive. Okay, even a, b, all are positive. Now, what is the specificity of this r? That r should lie r should be less than b and should be greater than or equal to 0. Correct? So, with this condition, if it is being satisfied, Euclid's division lemma can be satisfied. And we already studied. Then Euclid's division lemma is being applied to find HCF. To find HCF. Okay. So we went for finding HCF of two numbers at a time. At a time means we cannot take three numbers. At a time we have to take two numbers so that we can use Euclid's division lemma. By this Euclid's division lemma we applied and we found HCF of two numbers. Right. If you are having three numbers, then what you need to do? First you need to find HCF of two numbers. Then whatever HCF you have found, and then again third number you have to go for. Same procedure you have to apply, same process you have to do it, and then you can find HCF. Okay? Right. So this was the first topic. Then second topic what we studied? We studied fundamental theorem of arithmetic. Second topic was fundamental theorem of arithmetic. What this fundamental theorem of arithmetic says, that any composite number can be expressed as a product of prime. Composite number can be expressed as a product of primes, and this factorization is unique. See, if you are converting a composite number in the form of product of primes, it means you are factorizing. You are finding out its factor. Okay, so factorization will be unique. Though the order of this prime number factorization, it may be different. 3 may come at different place, 5 may come at different place. It's not necessary that always in ascending order or in descending order it will be following. Why it is being said as factorization will be unique? Okay, for each number there will be a separate primes. Right, but order will not be, order cannot be same. Order may be different. Okay, order may be different. So this is the fundamental theorem of arithmetic. Every composite number can be expressed as product of primes. Factorization will be unique and its order may be different. So this was fundamental theorem of arithmetic. On the basis of this, we took some number and we have converted as a product of prime. Like suppose if I am writing a number 100 is given to us, then we need to convert it as a product of prime. Then if we are writing 2 first, so 2 into. So here, for my reference, immediately I am writing 50. 50 is not a prime number, I know. But for my reference, I have written 100 as 2 into 50. Now what is my job is to convert this 50 into product of primes. So immediately I will rub it. Or we can say in second sentence I will write for this 50. So if I am writing 5 into 10. Again, till now it has not come and it is not satisfying this fundamental theorem of arithmetic. So immediately, next what I will do, this one I will write 2 into 5. Now you see that I have written 2 here, I have written another 2 here, not that in ascending order or in descending order. This order may be different. But this pattern, this unique factorization will be for 150. Okay? So it is 100 now is converted as a product of prime here. Right. Now this fundamental theorem of arithmetic we will be utilizing for finding out HCF and LCM. Finding out HCF and LCM. Third topic was HCF and LCM. Here also HCF we discussed. This HCF, to find out this HCF was different. Why? Because we were using Euclid's division algorithm or lemma. Here HCF we are finding out on the basis of fundamental theorem of arithmetic, means by converting the number into product of primes. Here HCF only we can find, LCM we cannot find here. But here, with this particular theorem, we are in a position to find HCF also, LCM also. Right. Now HCF is what? So it is product of smallest power. Product of the smallest power of common prime factors. Common prime factors. Very important for this HCF. Product of smallest power of common prime factor. So common and then the smallest power. Whereas LCM is product of greatest. Place of this is smallest, it will become greatest power of prime factors. All prime factors involved, all prime factors involved. greatest product of greatest power of prime factors involved. All prime factors involved. Smallest power, greatest power. Okay. Right. Very nice. So on the basis of this third, we will be finding out now HCF and LCM. Right. One more thing it is there. If there are, this is fourth one, if there are two numbers given, if only for two numbers, this particular criteria will be applicable for only two numbers. So if there are two numbers given, then product of HCF and LCM of two numbers is equal to product of the numbers itself. Product of the numbers itself. What is the advantage of using this? The advantage is you find only HCF or LCM, any one. You are having already two numbers. By utilizing the two numbers and converting it into prime factors, you are finding out only HCF or only LCM. If any one you are having HCF or LCM of that two number, another one you can find out immediately by following this particular law. Suppose two numbers are x and y. Suppose x and y are the two numbers given to you. You have already found LCM. Okay, LCM is known to you and that is Z. So it means HCF, which is P, I can find out by x into y, product of the numbers divided by LCM. Similarly, if I am having HCF, this LCM will come here, HCF will go there, so HCF will be able to find. So this is the advantage of using this particular law. Okay, so by utilizing these theorems, formulas and these particular rules, we will be solving question now. Okay. Okay, so we will go to exercise 1.2. 1.2. Question number 1 is there to convert the number in the form of prime factors. Okay, so let us do one question. Question number 1, that is to express given number as product of prime factors. Prime factors. Okay. So we are given a number, first one is 140. Suppose 140. Okay. So 140, as we know that it is divisible by 2. So immediately we can write as 2 into 70. Further, this needs to be converted as a product of prime. So again 2 into 35. Again we will be going for converting this one. So 2 into 2 into 35, which will make it as 5 into 7. It means this particular 140 number is being converted completely as a product of prime by this expression. This one, these things we can keep it in our rough portion. So this side we can make it, and you can say that fair one, you can keep it here. Right? Second, any other number, I will take it. So like 3825 is there. Third number we will go for. 3825. Okay. So what it will be? So we are going for, let us make that rough work here itself. So 3825. So we are already going to find factors. Okay, we are already utilizing this particular method. So as this number is having last number as 5, so certainly this particular number given is divisible by 5. So 5, 7, 35, then 32, 5, 6, 30, then 25, 5, 5, 25. Okay. Then again 5. 5, 1, 5, then 26, 5, 5, 25, then 15, 5, 3, 15. When you will sum this, 5 plus 3, 8, 8 plus 1, 9, and 9 is divisible by 3, it means this number is divisible by 3. So 3, 5, 15, and 3, 1, 3. Again, when you will add 5 plus 1, 6. Okay, so 6 is also divisible by 3. Then we can put it, we can divide by 3 again. 17. As 17 is a prime number, so further we cannot divide. Right? So here 3825 has become 5 into 5 into 3 into 3 into 17. Here we can write 5 into 5 into 3 into 3 into 17. So in this way we have converted the given number as a product of prime by utilizing fundamental theorem of arithmetic. Okay. Now we will solve question number 2, where we need to find HCF and LCM. Right. Let us go for it. I will write here, this is there. So we need to find LCM and HCF of given two numbers. Two numbers also may be given, three numbers also may be given, not an issue. By factorization, we can find for 3 number, 4 number, as many numbers given. But there is a limitation of utilizing that rule, that product of the number is equal to product of HCF into LCM. And Euclid's division lemma, there is a limitation that only 2 numbers we can find HCF. Okay, in question number 2 we need to find LCM and HCF. Okay, and also it is given that we need to verify. After finding LCM and HCF by fundamental theorem of arithmetic, we need to verify that LCM into HCF is equal to product of 2 numbers. We need to verify. Okay. So the very first question, 26 and 91 is given to us. Let us solve it. So 26 and 91, 2 numbers are given. 26, we will be going for factorization. Okay. So it is given to you, if 2 I am writing, then 2 we are dividing, it is becoming 2 into 30. Okay. Then 91. So it is divisible by 7 into 30. 7 into 30. 91. Now, the definition of HCF and LCM you will remind. Definition of HCF was product of smallest power. Product of smallest power of common prime factors. Product of smallest power of common prime factors. Now in this 2, which is common? So this 13 only is common. 2 and 7 is not common. 13 is also having power 1 only. Here also 13 is having power 1 only. So product of smallest power of common prime factor. So common prime factor is only 13 to the power 1. If nothing is written here, it means it is 1. So 13 to the power 1 is equal to 13. That will become LCM. HCF. LCM. Now again you will recall the definition of LCM. Product of greatest power of all prime factors involved. Greatest power of all prime factors involved. So here prime factors involved 2 is there. Here it is not there. So the power of this 2 will be 1 only. So it is 2. So 2 we will write again. Another one is 7. 7 will be coming as it is. Common this one it is there. Greatest power is also 1. So it is 13. Right? Okay. So this one will be given to us as 2 into 91. So 2. Because 13 into 7, 91. 91 into 2, 182. So our LCM has become 182. Our HCF has become 13. Okay? Right. Now next we need to verify. We have to verify now. So we will go for verification that our LCM and HCF is correct or not. So verification by this method. So now LCM into HCF. We will put LCM into HCF. So LCM is 182 into 13. So that is HCF. We will find out now. Second one, we need to find product of 2 numbers. Product of 2 numbers. So numbers given are 26 into 91 into 91. Okay. So this one we will find. How we will find easily? So we will write 182 into 10 plus 3. 13 we can write 10 plus 3. 182 into 10. 1820. Easy. Then we will multiply with 3. So 3 into 2, 6. 8, 3, 24. Then 2, 3, 1, 3. 2, 5. Just add it. 6, 6, 8, 5, 13. And 1, 1, 2. So 2, 3, 6, 6. Right. Further. Now product of 2 numbers. Okay. So this one, what we can do? 91 is there. 26. What we can write? 30 minus 4. Nearest 10. Okay. So 91 into 30. So 3, 1, 3. 9, 3, 27. So 2, 7, 3, 0. Again, 4, 1, 4, 9, 4, 36. We have to subtract. 10, 4, so 6. Again 12 and then 6. Here it will become 6. So here it will be 6. Then here it is 3. And then here it is 2 only. So 6, 4, 10, 6, 6, 12, 1, 13, 3, 3, 6, 1, 7, 2. 2, 3, 6, 6. Whether both are same? Both are same. It means we have verified. Okay, so in this way, verification also will be needed. So now that rule is correct, then we can certify by verification. Okay? Right. One more question we'll do for this one. Okay? One more question I will solve, and then remaining question we will solve in next class. Okay. Question number 3 is being given for 3 numbers. For 3 numbers. We'll go for question number 3. So this one, to find LCM and HCF of 3 numbers. First one. So it is 12, 15 and 21. 12, 15 and 21. Again, fundamental theorem of arithmetic we will go for. So 2 into 6. 6 can be written as 2 into 3. Then this one 3 into 5. Here 3 into 7. Now which is common factor? Common factor 3, 3, 3. So HCF, product of smallest powers of common prime factor. So common prime factor in all the 3 is only 3, and the smallest power is 1 only. So we can write 3 only because others are not common. Okay. Now LCM. So LCM will be, so here what is the power? If in the form of power you will be writing, then it will become 2 to the power square. 2, power 2 will be there. So can I write like this? We can write like this? Okay. LCM says, sorry, it is LCM. LCM says product of greatest power of all the factors. So greatest power, so first if we are going for 2 square, another place it is not there, so this is the only greatest power for 2, so 2 to the power square into. Now this 3 is common and the greatest power is also 1 only, so into 3. 5, another factor, its greatest power is also 1 only. Then 7, its factor, its also power is only 1, so 7. So this one will be giving you 4 into 5, 3, 15 into 7. Okay, you can write it as 28 into 15. So 15, 8, 120. So 0, 12, 15 to the 30 and 12, 42. So 420. So our LCM has become 420 of these 3 numbers. HCF has become 3. But here we will not be able to utilize this particular verification. This particular verification will not be able to apply. Okay? So in this way we will be solving questions. Other questions we will solve in our next class. Okay? Thank you.